Hello, welcome to YouTube channel Linga Reddy Chemistry JNE. Structure of atom chapter we are discussing. The main topics already we discussed. This electron proton discovery is over. After the discoveries, Thomson atomic model and Rutherford's atomic model also we discussed in the last videos. Now before going to Bohr's atomic model, we have to learn electromagnetic radiation. Okay, because Rutherford he failed to explain the hydrogen spectrum, line spectrum. Yes, as well the energy, how it is releasing from the atom even though it is stable. Okay, the electron energy levels, electron distribution, he could not explain. So now electromagnetic radiation, today video we are going to discuss. This electromagnetic radiation concept given by first James Clerk Maxwell in 1865. Here again it is given by two types. One is wave nature, the another one is particle nature. Few scientists told that it is in the particle nature, some are told that it is in the wave nature. So this Maxwell, he proposed wave nature, then Henry Hertz also he supported, then Maxwell and Einstein, these two scientists proposed particle nature. Particle nature, it's not only proposed means just theoretically, they showed some practical evidences. The Maxwell, he given that black body radiation explained by only wave nature, particle nature, as well Einstein photoelectric effect, he explained by particle nature. Okay, so initially it was wave nature, then later particle nature. After this Einstein, then we will discuss that the EMR has both natures, wave and particle nature. Electromagnetic radiation has two fields, electric field and magnetic field. You can see here the red one is electric field, the blue one is magnetic field. Each one is perpendicular. As well the propagation, the movement is in another direction, x-axis, y-axis and z-axis, right? So this electromagnetic radiation, some properties are there. The first one is wavelength. Wavelength means, see here, in between two successive crust and two successive trough, that is a wavelength. It is shown by lambda. Units of wavelength you can take centimeter, meter, angstrom, picometer, like this. 1 angstrom equal 10 power minus 10 meter. Then next property is frequency. What is the frequency? Here see one point is there. From this point within 1 second how many waves are moving, that is the frequency. It is shown by nu. It is shown by nu. The unit is hertz. See, velocity means what? Velocity means the distance traveled, the wave, how much distance travel in 1 second, that is the velocity. Clear? Wavelength means this is the wavelength. Frequency means within 1 second how many waves traveled, the number of waves, that is the frequency. Now velocity is how much distance traveled, this is the velocity. So okay, lambda, c and nu, ये तीनों का relation समझ गए now? Lambda is the distance of this one wave, total distance of wave within 1 second, that is equal to velocity, right? It is shown by c. Units of velocity, centimeter per second or meter per second you can take. Relation between wavelength, frequency and velocity is, you can see here, velocity equal frequency into wavelength. This is the main. Next, wave number. Wave number means within 1 centimeter how many waves are present. That is the wave number. It is shown by nu bar. Nu bar equal to 1 by lambda. The unit is centimeter inverse. You can take in the meter inverse also. Properties of electromagnetic waves. The propagation is opposite in direction of electric field and magnetic field. You can see the first point. These are oscillating on x-axis and y-axis. The propagation is on third axis. See the three differences: sound waves, water waves, and electric waves, electromagnetic waves. If we arrange the electromagnetic radiation by decreasing frequency or increasing wavelength or decreasing frequency, this is known as electromagnetic spectrum. This is known as electromagnetic spectrum. See, in this, only this visible part we can able to see. This visible range is 350 to 750 nanometer. So visible से more energy वाला UV होता है, ठीक है. Visible से less energy IR is there. Okay, then microwaves, radio waves. Frequency of radio broadcasting is around 10 power 6 Hz as well. Frequency of radars is 10 power 10 Hz. Particles wave nature successfully explain this interference and diffraction. It is successfully explained. See, this interference and diffraction you will learn in physics also. Suppose if it is in the particle nature, this light should come like a straight line. Then here also it would be like straight line. But according to Maxwell, this light electromagnetic radiation is moving as a wave. So these waves, so that's why this light is spreading like this, the cone shape. Yes. So here also, here there is no battery even though light will be there. Okay. So that thing can explain by only wave nature. We cannot explain by particle nature. So then diffraction, similar thing. It is spreading like this in the different angles. So that is explained by only wave nature. So this theorem successfully explained this interference and diffraction, but it could not explain this black body radiation and photoelectric effect and spectral lines in the hydrogen spectrum. These three experiments could not explain by wave nature. Okay, so for that we have to discuss particle nature. So the particle nature explained by Max Planck. What he given that black body radiation he explained. See, if you heat an iron nail or iron rod, then initially it is looks like, see, the red color, then yellow color, then completely white color. The red color energy is less. We know that in the Vibgyor color, red color energy is less. Then yellow color means it is more energy. Then blue is more. White means after blue it will come. So higher frequency, that means higher energy. Here we have to talk about black body. The black body means 100% absorber and 100% emitter. So complete energy it is receiving as well, complete energy it is releasing. Okay, that is the black body. See here, one slit is there, one small hole is there. So when the light is coming inside, it is completely inside only moving, scattering. So that means 100% absorber. When you are keeping at a hot surface, then the total light is emitting. 100% light is emitted by this body. This is the called black body. The color also black. Platinum coating was there. So it is completely black in color. So when they observed at a different temperature, they observed these two graphs. At this graph we can observe like this. At lower temperature and higher temperature, the peak is at low wavelength. Low wavelength means more frequency and more energy, we can say. At higher temperature, more energetic particles are maximum. Suppose 100 particles are there, 100 में around 80 particles are more energy. Okay, like that. So low temperature में out of 100 only 50 particles are there, more energy. That more energy also, see here, less number of particles. Fraction of the particles is less number. Here fraction of the particles is more number. So this thing could not explain by wave nature. According to wave nature, if more energy is there means the intensity will be more. Here actually it's a more energy. So more energy means the intensity should be more. The graph should come like this according to wave nature. So the graph is coming like this. Number of particles are less. Okay, intensity is less even though energy is more. Intensity is less even though energy is more. They could not understand why it's so. From wave nature we cannot explain. According to wave nature क्या है? Wave nature में E equal होता है, energy is directly proportional to intensity. This is the drawback according to wave nature. But later the particle nature came. Then particle nature say we can explain that it is not at all related to intensity. The energy is not related to intensity. The exact frequency distribution of the emitted radiation, the intensity wavelength frequency curve from a black body depends only on temperature. At a given temperature, this intensity of emitted radiation reaches maximum value and then starts to decrease with wavelength. Same graph is explaining. On increasing the temperature, intensity of emitted radiation increases and shift towards a shorter wavelength. This one is telling the third point. Next, a quantum of light radiation is called photon. Then Max Planck, he suggested a few things. The quantum of light radiation is called photon. If sunlight is there, the sunlight has photon, not proton. Proton is different. It's a photon. Some energy packet it is. Some amount of energy is there. The characteristics of photon. What is a photon? The source of energy emits radiation in the form of photons which travel with velocity of light. Suppose sun is there, the sun say rays are coming. Okay, these are coming like particles. Okay, each particle is called photon. The energy of photon E equal to h nu. अभी तक क्या था? E directly proportional to intensity was there, but now he is telling that E equal to h nu. If nu is changing, obviously energy will be changed. Where h is Planck constant, the h value is 6.626 into 10 power minus 34 joules second. Here the c is velocity of light, 3 into 10 power 8 meter per second. Right? See, quantum of light radiation is called photon. Characteristics of photon are all photons in vacuum travel with the same speed as velocity of light, 3 into 10 power 8 meter per second. Their speed changes in different media but frequency remains same. The photons are electrically neutral and are not affected by electric and magnetic field. Okay, the photons travel as wave but absorbed as particles. That means these are the like this protons. Okay, it is looks like wave, but it is not continuous wave. It is a discontinuous wave. Okay, this is the particle nature also. Then energy of the radiation is directly proportional to the frequency. E is directly proportional to nu. It is inversely proportional to the wavelength. E equal 1 by lambda. It is directly proportional to the wave number. E equal nu bar. These properties we discussed in the wave nature. Now some problems we will discuss. See here one problem. Find the energy of radiation of wavelength 300 angstrom is there. So energy find out karna tha. So E equal h nu or h c by lambda. Okay, lambda and c already we know that is given in the question. One thing you have to take care. Whenever is given in the angstrom, you have to convert into meter. Okay, so for that what to do? Just angstrom into 10 power minus 10, that is becomes in the meter. Then h value constant hai 6.6 into 10 power minus 34. C value also constant 3 into 10 power 8 meter per second. Then you will get this value